In 2021, Mount Nyiragongo erupted. The fastest lava in the world started gushing towards the city of Goma and Lake Kivu. Scientists were worried that this deadly event could trigger something even worse deep within the lake.
It will kill everything, humans, wildlife, and everything that will be all around.
An event that cannot be seen or heard, but could kill millions. It's called a limnic eruption.
Yeah, so limnic eruptions fortunately are rare because they're also incredibly dangerous. Around the world in very specific locations you have these lakes that are normally very deep and unlike other lakes they don't kind of overturn and squish around by the seasons very much. So these lakes first have to form in areas that are tectonically or volcanically active. When you have magma shifting about deep below the surface, this magma often has gases trapped in it. Carbon dioxide is a really common one. If you have a lake there that's incredibly deep, the lake acts as basically a storage device for this gas because the lake is so deep and the water at the bottom of the lake is under so much pressure that it acts as kind of like a vault for this gas. And the worry is that if you fill up the vault with too much of this gas, it will explode out of the lake. So it's a rare phenomenon, but it's unfortunately one that when it does exist, it's incredibly hazardous.
There are two ways in which these lakes can explode and release this toxic gas. The first is oversaturation, where there's so much gas stored that it cannot take anymore and needs to be released. The second is where something happens that causes a sudden mixing of the water. The troubling thing for geologists is that one of these killer lakes lies at the foot of Mount Nyiragongo, Lake Kivu. The concern is that large volcanic activity could lead to underground lava flows, which if they reach the lake, could cause the colder, dense water to warm and rise to the surface, which could potentially trigger an eruption. And that's what got everyone on edge in 2021. Something local biologist Prince Kalame, who studies the lake, remembers all too well.
The volcanic eruption of 2021 actually kind of surprised many people. Part of the city actually where the lava flowed, a number of houses were destroyed and very big part of the city going that side was actually covered by the lava. And so all the houses were covered and everything kind of melted with this very high temperature materials coming. But then when it comes to the lake, then that's where actually we have fear of a potential or possible limnic eruption because the lava could actually act as a trigger actually to get the CO2 from deep lake actually to come out. And so where you live, there is no more oxygen and people may die by suffocation. That is where the CO2 is very, very big problem actually. When there is a limnic eruption, the CO2 that comes out is the problem because it will kill everything, humans, wildlife, and everything that will be all around.
To be clear, these eruptions aren't just theoretical, they're very real, and they've happened before. Most recently, in August 1986.
The first accounts have started coming from northwest Cameroon about the disaster caused by a poisonous cloud from a volcanic lake. Residents in the area say around 90% of people in the surrounding villages were killed by the toxic fumes.
No one can kind of agree what caused the eruption. There's arguments it could have been an earthquake, maybe it was a landslide, but something basically caused all this trapped carbon dioxide to just erupt out, and this carbon dioxide just cascaded downslope and killed 1,700 people in their sleep and, many more animals. And I think, because it just wiped out all these villages so quickly and so stealthily, like no one knew what would happen until people turned up the next day and just saw all these people dead with no apparent external injuries. So it's quite a terrifying sight to behold. But yeah, unfortunately, this kind of disaster could happen again at that lake or other lakes around the world if something's not done about them.
There was no warning. The CO2 flooding down from the lake had no smell and no visible signs.
That eruption in 1986 really kind of underscored how dangerous these lakes could be. It really made a point of this kind of disaster can happen. And I think it really woke up the scientific community, but also just the region to the dangers that these lakes can pose.
After the eruption of Lake Nyos, scientists began looking for solutions. Michel Halbach was convinced there was a way to avoid another disaster by releasing the trapped gas at the bottom, but first he had to prove it.
On est arrivé à Nyos. Il y avait une très bonne équipe de soutien. J'ai acheté 200 mètres de petits tubes. Je me suis procuré ce qu'on appelle une pompe pyroclastique. C'est simplement une pompe qui aspire le liquide et qui le rejette. Bon, on a pompé, et à un moment, on a vu apparaître le liquide. Le liquide est sorti, il apparaît quelques bulles, puis plus de bulles, on a arrêté la pompe, le jet a augmenté, et on a vu apparaître un jet de 50 cm de haut qui crachait en permanence. On a arrêté la pompe, ça marchait. Bon, c'est la démonstration qu'on peut vider ces lacs, simplement.
And that's exactly what they did. After the successful demonstration, the team installed larger, permanent systems which successfully degassed both lakes in Cameroon, preventing another disaster and potential loss of life.
Je suis très fier de ce qu'on a fait. D'ailleurs, bon, même au Cameroun, c'est connu maintenant. C'est connu que les lacs sont inoffensifs.
The efforts were extremely successful, and the lakes have now been declared safe. Now attention has turned to solving the issue of Kivu. There are some upsides and downsides. The downsides being its size, 2,000 times bigger than Neos. Degassing it is a huge undertaking. The upside is that one of the gases in Kivu that's causing the pressure is methane, a gas that can be used to create energy.
In the case of Kivu, the situation is a very different one because there the methane gas, which causes most of the gas pressure, has an economic value, and so the logic thing is then to use the gas and then have the double win-win situation, producing energy at the same time and as reducing the risk. Once the methane is basically used up, then and only the CO2 is left, then the danger is very low. Then basically the danger has been removed.
A power plant has been built floating on Kivu and is currently producing 25 megawatts of power. In the next few years, they hope to increase this to 100, doubling the total amount of energy production for the entire country. A welcome benefit for many living in the region.
In a country where we've got actually a deficit, that kind of a problem with electricity, it's actually, people are very exciting actually to know that something that is dangerous could be used for a potential actually or economical incentive actually to produce electricity that will develop many other structures like factories or whatever that can be used actually all over in the lake shore.
It's been suggested that a safe and reasonable timescale to use up this methane is around 50 to 100 years, so it's feasible that in the near future, this killer lake could be declared safe. And it couldn't come any sooner. Still to this day, the effects of these eruptions serve as a reminder that if nothing is done, the unthinkable could occur.
Check that out, man. That's the volcano eruption, the cloud.
In January 2022, the planet had a near miss. Satellite imagery picked up signs of a vast underwater eruption. This footage was taken moments after. The Hunga Tonga Hunga Haipe eruption was so large, it sent a sonic boom around the world twice, and the internet went bonkers. It was the largest eruption of the 21st century, from a volcano over 20 kilometers wide, sending water and ash 58 kilometers into the atmosphere. But it might not stay the largest, because around the world there are at least 12 even bigger volcanoes with the potential to blow. Supervolcanoes. So I decided to go digging.
It's a dead certain that we'll have something very large in the next few centuries, for sure.
A supervolcanic eruption will lead to planetary-wide devastation, but luckily for us, the brains at NASA may have come up with a solution.
I was on the Committee on Planetary Defense looking at defending the Earth from asteroids and comet impacts. It became evident to me that the asteroid impact problem, although a serious problem, an even greater problem is the supervolcano problem.
It's not good news. But before talking to Brian, I first wanted to find out exactly what this supervolcano problem actually is. How bad would one of these eruptions be? And more importantly, what are the chances of one happening in the first place? So I headed off to meet scientist Dr. Lara Mani at a place where all they do is study things that can kill us. The Centre for the Study of Existential Risk.
We mainly focus on large magnitude eruptions, Or you might have popularly heard of them as super eruptions or supervolcanic eruptions or supervolcanoes. These kind of supervolcanic eruptions are VI8 and VI9s.
Okay, so this confused me slightly. So let me try and explain. Volcanoes are measured on something called the Volcanic Explosivity Index. The scale goes from 1 to 9 and it's logarithmic. With each jump it increases tenfold. So 2 is 10 times bigger than 1, and 3 is 10 times bigger than 2, and so on. And by bigger, what they mean is how much material has been blown up and released from the magma chamber. The Hunga Tonga Hunga Haipai volcano was at a level 5, but there are at least 12 supervolcanoes around the world capable of eruptions 1,000 times larger than that.
The reason that we're interested in these larger type volcanic eruptions are because they can have severe global consequences. So eruptions of this size could potentially loft enough ash and gas up into our upper atmosphere that can cause global climatic cooling. And this is something that we've seen throughout history with the 1815 Tambora eruption in Indonesia that led to the year without a summer in 1816. And what we saw was the Thames in London froze over in summer, and we lost major swathes of crops in the Northern Hemisphere, and that this led to a huge food shortage and price spikes. Volcanic eruptions, if this large, would affect nearly everybody.
How real is the possibility that one of these large-scale eruptions could occur?
New studies are starting to suggest that it could be as much as 1 in 6 per century. That's a recurrence interval about every 600 years. It's actually really frequent.
Compared to other threats we see, like asteroids and comets, how likely are these large-scale eruptions?
The threat posed by these types of impacts are 1,000 times less likely than those posed by large magnitude eruptions. But yet we're doing very little in terms of preparing or thinking about mitigation of that risk.
How underprepared do you think we are?
So in January 2022, we had a very large, the highest intensity eruption ever recorded on modern instruments. But I would describe this as our near miss. Had this gone slightly differently, had the eruption lasted longer, we could be having a very different conversation right now.
With these large-scale eruptions, is it a case of when rather than if?
It's a dead certain that we'll have something very large in the next few centuries, for sure.
I have to admit, I came away from that conversation terrified, but even more eager to hear from former NASA engineer Brian Wilcox about a potential plan to prevent a supervolcanic eruption. So what is it you actually proposed?
Well, I proposed that we study the problem to see if there was a way to, an engineering solution that was practical within something that humans might be able to actually do in the relatively near future to prevent a supervolcano from erupting. And we chose Yellowstone as an example.
Yellowstone is one of the largest volcanoes on the planet, and a volcano that some believe is due an eruption. So trying to stop it erupt might not be the worst idea in the world. Brian's plan was to cool down the volcano, reducing the pressure in the magma chamber and therefore also the chances of an eruption. So I guess the logical next question is, how on earth do you go about cooling down a supervolcano?
Well, basically the concept is to drill 200 pairs of holes around the perimeter of the magma chamber. And so you'd be far enough outside that the rock would not be fractured and you wouldn't risk triggering an eruption by possibly opening a pathway to the magma chamber. So you would drill down and then circulate cold water into half of the tubes, would carry cold water down, and then the other half would carry the hot water up. As soon as you got to the point where you were pulling heat out at the same rate that it was coming in, you would effectively have reduce the likelihood of an eruption, by a tremendous amount. And then eventually, after 50,000 years, you would have cooled the magma chamber off completely.
50,000 years. He says it like it was nothing. However, despite taking 50,000 years to fully cool down, Brian explained how, with every degree that is released, the probability of an eruption reduces, so results would be seen instantly. It also got me thinking that if there's that much heat being released, couldn't we harness this for our own purposes? Wouldn't power companies be all over this? So if there is that financial incentive for geothermal energy companies to actually do this, I guess why hasn't it been done?
So the problem is that the cheapest thing to do is drill right on top of the magma chamber and get to the hot rock with as short a drilling path as possible. That would affect, Old Faithful and all the other geysers and natural features there. So that, that is abhorrent just from a kind of an environmental point of view. But also it does risk setting off the volcano. There's absolutely some risk that you could trigger an eruption. If you cooled it too fast, you might force the gas out of solution and cause an eruption. The exact thing you were trying to prevent would have in fact been caused by your action. So we don't want to do that.
No, Brian, we definitely don't. So not only is an eruption coming, most likely, we're also grossly underprepared. Brilliant. And if we want to stop it completely, it will take 50,000 years. Just as I thought my investigation was over, I heard back from a scientist who may have the answer to protect us against volcanic eruptions. Remember how earlier Brian said that if you drill directly into a volcano, you risk triggering an eruption? Well, it turns out there's a power company in Iceland that's done exactly that. So this is what happens when you drill into a live magma chamber by accident.
This was a serendipitous encounter, so it was not planned for. In fact, with some of the best geophysics that we have in the world, we did not know that the magma would be encountered at 2.1 kilometers.
Luckily for them, it didn't trigger an eruption.
What they did then is they decided not to go further, but then they decided to produce energy. So for them, they managed to produce about 50 megawatt of energy, which is about 10 times the average well in Iceland, which is a lot of energy.
More excitingly, scientists believe that this window into a live magma chamber can help us forecast and even predict eruptions, allowing us to better prepare and protect ourselves.
Right, instantaneously, the minute all of us have heard about that, we thought, that's our way in, right? Because if anyone had said, we would like to get funds to drill in a magma reservoir, anyone would say, no, there's probably too much danger. It is truly transformative. Eventually, if we can actually understand what happened to the magma in situ, we might be also able to predict volcanoes. And that is quite a big word. We don't predict volcanoes. We don't know what's going to happen.
Is the ultimate goal to have setups like this one in different places around the world so that we can monitor different types of lava and different types of volcanic activity?
Ultimately, what we learned there, essentially, which is how to drill into magma, sample magma, instrument magma, and manipulate magma, needs to be utilized elsewhere down the line. That's one of the goals. But we need to learn to do this safely in one place before we can simply bring that technology elsewhere.
Before delving into this, I had no idea how great an issue these supervolcanic eruptions are, and I can't say it isn't worrying that no one denies that one is coming. It is, however, reassuring to know that there are scientists out there actively looking for solutions. Maybe not to stop an eruption, not unless you want to wait 50,000 years, but to help understand them and the risks they impose. I think it's probably the uncertainty that stops people taking it too seriously. At least with an asteroid impact, you can calculate exactly when it's going to hit and then take some action. But it's clear that more needs to be done, but hopefully by making people aware, it might shed some light on this potentially existential risk. Hidden within Earth's ice lie some nasty surprises. In 2016, news emerged of a mysterious disease that was tearing through a community of nomadic herders in northern Siberia. It killed over 2,500 reindeer, with dozens of people hospitalized and many more evacuated. The cause was anthrax, ancient anthrax, because the outbreak had been triggered by spores of the disease that had somehow managed to survive for decades in a deer carcass buried deep within the permafrost. Then, in 2021 in Tibet, scientists found even more ancient viruses buried within the ice in the Tibetan plateau. They had somehow managed to survive for 15,000 years, and these viruses were unlike anything scientists had seen before. With the world's ice melting, what else is waiting in there for us? So I decided to find out whether this threat is real.
Worst case scenario would be that an old bacteria could show up again.
And the scale of the problem completely blew me away.
There is going to be so much misery, there is going to be so much violence. I think of those viruses and those bacteria like a machine gun. Climate change can pull the trigger.
Before getting ahead of myself, I first wanted to find out how and why anything can survive frozen in the ice for thousands of years and then suddenly spring back to life. So I started with a scientist who spent his life studying microbial life in the glaciers in Greenland.
They have mechanisms that can make them freeze in without actually dying. So they go into a dormant phase. It's like a hibernation for microbes and keep going for, sometimes in permafrost, you can see microbes that they have been million years. The moment that they is melting, they can very quickly switch on and then start to be very active. If you freeze your microbes and then you, from glaciers particularly, 50% of those microbes will start to be very active just after 1 hour.
1 million years frozen in time, then suddenly back again. It's a pretty scary thought. But not all viruses and diseases affect humans, and maybe the anthrax case was a one-off. Well, to find out more, I got in touch with infectious disease expert Birgitte Evengard, who's been studying the topic for over 40 years and specialises in climate-related risk. Is there actually a chance that these diseases being released could be damaging to humans?
Without doubt. Worst case scenario would be that an old bacteria that were around very many years ago could show up again. And also there could be antibiotic resistant bacteria emerging from the permafrost. So let me say, we don't know that much. We don't know anything, I would say. We just know that we don't know enough.
Most of the areas we're talking about are very remote. How would these viruses actually affect humans?
We have species on the move. Humans don't move that much with climate change, not yet. So the animals are moving towards the poles. Of course, with animals bringing with them the biomes, the bacteria they have in their stool or viruses, they bring into virgin areas.
So it's clear that there's a lot that's still unknown, and I think that's what makes it more terrifying. Recent publications suggest that there could be up to 1.7 million unknown viruses in circulation right now capable of infecting humans. So adding viruses from up to 1 million years ago into the equation is a pretty unsettling thought. What did interest me, however, is that we do know that the melting ice is causing animal movement, and with that movement, viruses and disease. So this made me think, are there other ways that climate change is spreading viruses? So I scoured through the depths of the internet, and what I found shocked me. This website takes all of the effects of climate change and reveals how they are exacerbating the spread of viruses and disease. And it's not just one or two, there's loads. So needless to say, I had to find out more. So I spoke to one of the scientists who put this study together.
So we analyzed all of the human diseases since the end of the Roman Empire until now, and we were looking at the extent to which any of those diseases, there is empirical data to suggest that climate change has had something to do with those diseases. And we found that 58% of all of the human diseases have been at some point aggravated by climatic changes that are the consequence of greenhouse gases.
Over half of all diseases have been affected by climate change. That's staggering. And it's also something that Camilo knows all too well.
I found a paper making the connection between an outbreak of chikungunya virus here in South America, in my country. It almost destroyed the economy. People couldn't work, okay? We're talking millions of people sick with this disease. It turns out that this scientific paper made the connection between floods and the chikungunya virus. And it turns out that I was infected with the chikungunya virus during that epidemic. I remember myself wanting to die during that week. My skin is full of blisters. I wanted to pull off my skin out of how much pain I was during that week. This one outbreak was caused by massive floods that caused a spike on the mosquito populations. That was a shocker, to say the least, when I personally realized that I was already a victim of this issue of greenhouse gases.
If we don't change and this continues, how bad do you think it could get?
I think that what is going to happen is a lot of human misery. There is going to be so much misery. There is going to be so much violence. It's going to be so freaking scary, man. I think of those viruses and those bacteria like a machine gun. Climate change can pull the trigger on those viruses in 1,000 different ways. And you don't know what kind of machine gun is going to be shooting. And I love it, no offense, that many of these consequences are being felt in the developed world. For them to freaking realize that we're destroying the planet, you know?
Do you think it's too late to turn things around?
I don't think it's too late, man. I refuse to think that it's too late. You can imagine in 100 years' time, the history books looking at the misery that we left for them, saying that it was us, the ones that we failed. I just don't want to feel responsible for this thing. I'm working my ass off to work on ways to fix this.
He's brilliant, isn't he? So not only may climate change release a whole new spree of deadly viruses, but it may also accelerate the spread. Great. Just as I thought it was all doom and gloom, Alex got back in touch as he thought I might be interested in an area of his work that might suggest that viruses being revealed on the ice might actually help to slow down the melting of the ice caps by stopping algae. So of course, I had to hear more.
There's so much life on the ice, more than you expect. But one particular type of life is the growth of algae that grows on the ice. And these algae is extremely dark and pigmented. Because they are dark, they also end up melting the ice. And part of that growth is because of climate change. I would say that it's about 10% more ice is melting just because of the biological presence of the algae. It's equivalent of every year another 4 million Olympic-sized swimming pools of water coming out from Greenland, basically.
In a bewildering turn of events, Alex's research suggests that viruses could actually be the key to slowing down this phenomena.
Just like they infect humans and then they are negative to humans, they can be negative to the other organisms that they are infecting. So they actually could potentially be a control of the biomass growth of this dark pigmented algae. From our perspective, it actually has a positive impact on a climate problematic organism.
So in layman's terms, viruses are actually helping to reduce the effects of climate change?
Potentially, in that particular situation, yes. Yeah.
Well, that took a twist. It's almost easy to personify these viruses as these evil organisms out to get us. But as you just heard, in some scenarios, they're actually vital in order to maintain the delicate balance of nature. It's only when we intervene by warming up the planet that suddenly this balance gets tilted. So not all viruses are bad, but we only have to look at COVID to realise how quickly these things can spiral out of control. And the worrying thing for me is neither Camilo, Birgitta or Alex deny that things can get a lot worse. So how do we stop it? Well, it seems undeniable that if we want to stop the release of these viruses and reduce the spread, we need to deal with climate change.
The thing that blows my mind is that these things, when people talk about climate change, they talk about let's do it in 2050. What the hell is... Basically, when you say let's do it in 2050, you are saying I'm not gonna do it. Is this freaking passing around the responsibility of things that they need to freaking do? The thing that blows my mind is the fact that indeed we can do things right now to deal with this thing heavily. The technology is there, the manpower is there. Fixing climate change is also gonna require the awareness and the commitment of people like you and me and everyone in the community, because we also keep expecting that our politicians, the ones that are going to fix this, and they had a lot to do, but they are not the only ones.
There's an ambitious plan to stop hurricanes in their tracks, using bubbles.
You think you must be crazy?
Yep, bubbles. And tests are already underway. Here's why we might need it. Hurricanes are getting stronger. Scientists say that rising sea temperatures are fueling hurricanes and making them increasingly fierce. This was Hurricane Katrina in 2005. In just one day, it was responsible for 40% of all hurricane-related deaths in a 50-year period. And since then, 9 major hurricanes have made landfall in the United States alone. Modelling also suggests that there may be a 20% increase in major hurricanes globally by the end of the century. Given the scale of the problem, you'd think it might be impossible to solve it. But there's a scientist in Norway who's helped develop a technology using bubbles that might just be the key. It seems like an out there idea, but when it comes to the world of geoengineering, nothing has been off the cards. Scientists have been trying to engineer their way out of a hurricane since at least the 1960s.
Project Storm Fury, a joint effort of NOAA, the Navy and the Air Force.
In Project Storm Fury, scientists thought that they could artificially create a new eye wall, which would clash with the original one and weaken the storm. That unfortunately failed. More recently, scientists suggested spraying fine seawater droplets into the sky to reflect away the sun's rays and thus cool the sea. This is still being explored, but it's at very early stages. Other gems proposed include towing icebergs to cool down warmer seas, purposely making oil slicks on the sea surface to prevent evaporation, and anti-hurricane jet engines on barges that would literally suck the heat from the ocean. Obviously. Some have even suggested that shockwaves from a nuke could disrupt the hurricane and weaken its process. Thankfully, that one's not being seriously considered. But let's get back to the bubble idea. And yep, I know what you're thinking. How on earth could bubbles possibly stop a 100-mile-an-hour hurricane? But the interesting thing about this plan is it's already been through various trials and simulations, and there are actually plans to start trialling this in the real world. So I tracked down scientist Grim Eidnes, who first developed the idea at SINTEF, a Norwegian research agency, having been inspired by a traditional Norwegian technique of using bubbles to prevent fjords from freezing over.
A bubble curtain is a perforated tube that is submerged into the sea, into the ocean. The bubble curtain in Mo i Rana, for instance, is keeping the area around the bubble curtains free of ice. The way we do this in Norway is to lift up the lower layer of warmer water up to the surface, where it mixes with the cold water and thus changes the temperature of the surface water.
Grim wants to flip this idea around and take it to the tropics, using it against hurricanes, where water from the depths is colder and therefore can be used to cool the surface temperature. To understand their plan, we're first going to need a crash course as to how hurricanes actually form, because sea surface temperature plays a massive role. So a hurricane is born as a pretty innocuous tropical storm, but when that storm passes over warmer seas, typically that means temperatures above 26.5, then this warmth fuels and feeds the storm, intensifying it into a full-blown hurricane. It does this because large volumes of evaporated water from the sea surface rise to form huge storm clouds, which are often rotated by very strong winds. And if those wind speeds exceed 74 miles per hour, boom, you've got yourself a hurricane.
26.5, you cut off the energy supply. If it's 30.5 or 32 degrees Celsius, then a lot of energy could be transported up to the hurricane.
So 26.5 degrees, that's the sweet spot. Below this temperature, there's no net feeding of the hurricane, stopping it from becoming more ferocious. That's why sea surface temperature is at the heart of the bubble plan, by pumping up colder water from the depth to the top and therefore lowering the temperature. But if pumping up water is all that's needed, why can't they just use pipes?
That has been suggested by several people. Cold water is heavier than warm water. It will be too heavy and sink down again.
So bubble curtains act like a blender, creating this mixed layer and keeping the water cool, with the ocean currents also helping to spread this effect to larger areas. Sounds handy, especially since hurricanes can span hundreds of miles. Depriving hurricanes of its food source using this cold water blanket is an ingenious plan. But is there any proof it actually works?
We have performed a proof of concept with real weather and real temperatures.
This computer model shows how cooler water caused by the bubble curtain spreads using natural currents. This simulation showed that in 40 hours the cooler water spread over 60 kilometers. So, they've shown in theory that this bubble curtain can affect the temperature of a large area of the ocean's surface. The next stage is to run a larger simulation on historical hurricanes. But what about trying it out in the real world?
All the tests you have in Norway are very shallow water models. And when we talk to the Gulf of Mexico, we talk about 50 meters, maybe 100 and even 150 meters depth. That's why we went to 1 weekend, to try to have at least 50 meters of test.
Once these trials are complete, the endgame for Grim's plan is to have a series of bubble curtains, towed along by tugboats. But for all that to work in real-world context, there's still one massive hurdle they'd need to overcome. They'd need to rapidly deploy the boats to the right place at the right time, and in order to do that, they need to know exactly where and when the hurricane is going to form. So I took a trip to the National Centre for Atmospheric Science to meet meteorologist and climate risk expert Dr. Liz Stevens to find out just how difficult it is to prevent a hurricane.
We're very good at being able to forecast the track of hurricanes further in advance, but sometimes we miss the exact intensity that those storms will be.
Modern-day computer models struggle to capture this intensity. We just don't have enough information on the small physical events happening within the centre of the hurricane. In the US, pilots actually fly into the centre of the storm to gather this crucial data directly.
We've seen tropical cyclones in recent years that have rapidly intensified even less than 12 hours before they've made landfall. And this hasn't been something that's been well forecasted.
Even with all the cutting-edge satellites and weather models, it's still very tough to predict hurricanes in advance. So for some people, defense rather than attack is still our best bet when it comes to dealing with hurricanes.
The best way to reduce the impacts of tropical cyclones and hurricanes is to ensure that we are building houses and infrastructure to withstand them. And that means building them with stronger roofs so that we're really reducing the impacts.
Actual physical barriers like flood walls can be a game changer when it comes to things like storm surges, where the strong winds cause the sea to rise, which is often the leading cause of death from hurricanes. The Thames Barrier, for example, shields London from storm surges and flooding, but in areas of the world unable to afford them, natural barriers like mangroves and wetlands can be really effective in protecting coastlines. There's another big concern about geoengineering though.
Geoengineering might do well at reducing temperatures and reducing the risk of heat waves, for example. In other parts of the world, it could end up perhaps restricting rainfall, which could lead to more droughts.
This seems to be the general consensus among many scientists skeptical of geoengineering. Whether it's droughts or affecting marine ecosystems, how do we avoid an even bigger problem from the knock-on effects of meddling with nature? It's a crucial area that the bubble plan doesn't seem to be addressing just yet.
There are things with respect to climate, with respect to ecology, that I want others to look into. And we have started this to find out the best companies to do this work for us.
If further trials and simulations are successful, the final gear in Grimm's plan is a full-scale demonstration in the Gulf of Mexico, a hotspot for hurricanes.
If you have some good warnings that it comes to this location, the track will be there and there, get some vessels going there immediately and they can do it now. So as long as the forecasts of the trajectory of the hurricanes is good enough, we can act on them also.
Clearly the jury is definitely still out, but unlike most geoengineering ideas, this one's actually going ahead. So it'll be interesting to see what happens in the coming years.
If the bubble curtain showed to have a real impact on the hurricanes, I think I would be glad, and I would certainly smile, and I would feel relief.
Until then, it doesn't seem like a bad idea to take Liz's advice, that defense can really be the best form of attack when dealing with hurricanes. By beefing up natural barriers, bolstering storm defenses, and improving early warning systems, and critically, preventing further sea temperature rise by addressing climate change. Toads predicting earthquakes and birds predicting tsunamis? Really? I know, but hear me out. The idea of animals having a sixth sense has been around for centuries. Well, now there's some fascinating research showing that not only may this be true, but scientists are now genuinely exploring whether animals could be used as early warning signals for natural disasters. To find out if animals really are the future of forecasting, I've travelled to meet one of the leading animal behaviour experts, Dr. Rachel Grant, who accidentally discovered an animal with an earthquake-predicting superpower.
I was doing my PhD on the reproductive behaviour of amphibians, i.e. toads and frogs, and I was doing my research work, my field work at a small lake in central Italy called San Rufino Lake. And one year I was doing my survey as usual, and the toad numbers were starting to increase towards the full moon, just like every other year.
Yes. Rather than just mating when they feel like it, toads use the lunar cycle to set a date for mating, to ensure enough male and females come together. And when better than a full moon? It's quite romantic when you think about it.
And suddenly, about 5 or 6 days before the full moon, there were no toads. There just were none at all. 5 days after the first toad disappearance, a large earthquake occurred about 50 miles away in the town of L'Aquila.
You can see fragments of the homes that existed.
Every fissure, every crack, a glimpse into how the familiar and cosy suddenly became sinister and dangerous.
This is a city and a country in mourning.
In the aftermath of the earthquake, it dawned on Rachel that there might be a link between the toad disappearances and the earthquake.
The really interesting thing, and that's the thing that convinced me, was after the earthquake, the toads all started coming back.
In order to convince geologists that this was legit, Rachel needed something more concrete than just a one-off correlation. Rachel scoured the globe for data sets of animal movements and came across a series of camera traps being used at the Yanachanga National Park in Peru. And bingo. Luckily for Rachel, there had been an earthquake during the same period as the study.
What I found was, as the earthquake approached, animal numbers started dropping. But the thing that sort of made my blood run cold almost was when I looked at the day before the earthquake, the 24 hours before the earthquake, there was not a single animal recorded. Once the earthquake had occurred, the animal numbers started going up again. So it was a very similar effect to that I saw with the toads.
So I guess the next question is, how on earth are they doing it?
What I found was really interesting. Usually there are radio waves transmitted from transmitters to receivers all over the world. I took a control path, which was just a radio path transmitted across Italy, and then I took a path which had passed quite near the epicenter of the earthquake, and there were fluctuations in these waves around the same time that the toads had disappeared. And I didn't really know why. I had no explanation for this at the time, but I just noted that these two things happened at the same time in the same place.
So the fluctuating radio waves clearly showed that something was going on. But what? What links those two things? After some conversations with NASA scientists, Rachel discovered a clue.
When rocks are under a lot of stress and about to break, just like happens before earthquakes, charges pass along the rocks when they're under pressure, and when they reach the rock-water interface or the rock-air interface, they cause ionization, which is basically charged particles.
It turns out that these charged particles have been shown to affect radio waves, and it's thought that these charged particles are what the animals are picking up on.
When I realised that this was the link, I was very excited, and for the Peru paper, I needed to find out if there were similar radio wave fluctuations corresponding to the animal disappearances. And we saw it again, radio wave fluctuations outside the normal range at the time when the animals had disappeared.
Suddenly you find the missing link.
I found the link between the radio wave fluctuations and the animal disappearance.
Rachel had finally shown a clear and undeniable link between earthquakes and changes in animal behaviour, which could provide a foundation for a whole new field of science that could help mitigate and forecast earthquakes. But Rachel is not alone in her research, and over the last decade, interest in using animals as early warning signals for natural disasters like cyclones and tsunamis has garnered more and more attention. This is Frederick.
I can take a very French accent if you want.
Frederick was contacted by the French military, who were looking for better ways to forecast cyclones and tsunamis after hearing reports of strange animal behaviour from the media, and thought birds might be the answer.
And then he contacted me and many others saying, I don't know if it's a crazy idea, if it's a dump or if it's revolutionary, but you are specialist of birds. Do you think it's interesting? Because we in the army, if it is, we are interested to fund it and to help.
Needless to say, with the promise of funding and military boats, Frederick said yes. So now they're in the middle of a long-term study tracking migrational birds in French Polynesia, a place that's especially prone to cyclones and tsunamis. They think the migrational birds are able to detect the low-frequency sounds, infrasound, that cyclones and tsunamis produce. So they are monitoring the birds with military-grade GPS trackers to see how their behaviour changes when tsunamis and cyclones form. But fitting them was easier said than done.
And the first expedition, it was like mist nets, like hunters trying to understand how to approach a bird to 20 meters. And the last expedition, it was like just harvesting them by hands. You go at night, you find the bird with a thermal binoculars. Now it's not that difficult if you go at the right time, at the right places.
Frederick is still in the middle of gathering data, but he hopes that if he can match the bird behaviour to impending cyclones and tsunamis, he can provide an additional natural early warning system.
So the idea is to propose a local warning systems which will be complementary and say, okay, there is an alert, be careful, a tsunami could be coming, and then yes, it is coming because the birds are escaping. And then be able to say, normally the birds escape 10 minutes before the wave, or 15 minutes or 5 minutes, and this will also be an information saying when this behavior is detected, you have 5 minutes to go to the rescue building to prepare in advance, even saving
10 minutes or half an hour, it can save lives and many things.
In the next few years, Frederick will be able to say for sure whether birds are able to forecast tsunamis. And if his hunch is correct, then this could be a game changer. Since Rachel showed that animals can be used to predict earthquakes, people can no longer dismiss the idea that animals may be better at forecasting than us. And this is only the start. Who knows what other bizarre and incredible things animals are able to do?